Okay. So, testing, testing, testing. Why? Spare me some time. Let me debug something. I'm not sure why there's humming issue. Testing. Okay, that should be all. Can you all listen? Those from online. I'm not sure why. So weird. Since I already exit my account, I still recording when I'm back. Okay. Let us continue. If you all cannot listen to me or any technical issue, please drop me a message. Um, Today I may need to end end this lecture maybe 5 minutes earlier. I have meeting later on, so perhaps we let's see how the progress. But I think the remaining lectures we have for today is quite short lah. Okay, so let us finish today. I mean for today only lah. We finish the remaining of the lecture and then we end our class. Okay, this is the last lecture notes we have. Okay, so after we complete this one, we will start. Today we don't have any tutorial, so we will start tutorial by next Tuesday. Okay. I will upload the remaining tutorial. So you all try to complete as far as possible. And then later on from next Tuesday onwards, we will start to discuss tutorial until we finish all the tutorial. And then we will go for revisions. So now is week 12, right? 11, 12, 11. Now week 11. So we have 3 weeks to go. I believe you can finish all the tutorial by next week. Perhaps the next tutorial, which is next Tuesday, 4:30. If let's say we finish all the tutorial lah, so we will start revisions. Okay. Since we have plenty of time to do the tutorial, so I will not present the answer lah. Instead, I will ask each of you to answer the questions. Okay, so be ready. Get yourself to complete the tutorial and get ready to prepare the questions. To share your screen or share the answer in the chat box. Okay. So and at the same time, if you have any questions, which chapter or which part that you maybe you may need revision, please let me know. You can jot down, and then either you can ask, you can let Chia compile and then send to me, or you can email me directly, either way. Okay. So another thing is that please remember to submit the assignment on time. Okay, so let us continue. Okay, B frame. So in the previous lecture, we did mention about three different types of frame, which is I-frame, P-frame, and also B-frame. So I-frame is the reference frame whereby you have it is independent, which means it does not need to dependence to any of other frame. Um, it can stand alone over there. Okay, it can stand alone. So that is so-called the I-frame. So in each of the in one video, usually we have several the video encoder or the one who manufacture or render the video, they will actually chip in the iframe with a fixed interval. It depends lah, not a must a fixed interval, but just that it won't just chip in two iframe for the entire video like for 3 minutes. It is not so logic because whenever you have because P frame and B frame is depends on other frames, either P frame or B frame. So it's not logic that you have only one or two iframe in one video. With a lengthy video. So the lengthy video so-called is more than 1 minute. So it's not so practical because when you have only one of few iframe in a lengthy video, once your iframe is being is corrupt, so the rest of the frame cannot be displayed, or it can be displayed but with a lot of different artifacts. So this is not something that we want. So this is not something that we want. So in order to avoid this one, this issue, so basically the iframe will be chipped in into the video with a specific interval. Okay. So B frame, we have another frame is P frame. P frame is is to predict from the previous one. So let's say you have different frames. This is starting from 0 to infinity. So P frame always quote something else from the previous one. Excuse me. Quote something else. Quote something the differences are so called from the previous frame. So this is so called the P frame. Okay, P frame will never get something from future, only the B frame. Okay, so the B frame is the only frame that will get the information from previous and future. So so called the bi-directional predictive coded frame. Okay, so the B-frame provides the highest level of compressions. Due to unexpected movement in real scene, the target macro blocks may not have a good matching in the previous frame, especially something that is coming in the future. Because if you want to predict something else, you need to know the current state. I think in control system you all did learn what else? SSM, state equation, sort of. I think something called SSM. You have your state equations and your output equation. So for state equation, you need to know the current state and the input state, and then you predict the future. It is something same like the control system. So you need your information, which is the current information and the previous information, so that you can predict something in future. So this is what the P frame and B frame is going to do. But nonetheless, since you have a video, you, for example, you have A frame and B frame. So between A and B frame, you have an interval. And this interval, maybe something new happens here, but this object is not exist in the previous frame. So the B frame function is to get this into this frame and get the rest of the characteristic from the previous frame, so that you can see a continuity in from the continuity in terms of transition of motion from A to B. Okay, so this is the example that I mentioned. So let's say you have an iframe here. So after you, this is the main frame lah, which means it is the independent frame whereby so-called the reference frame lah. So the next P frame is coded something from the previous one. And then you have another B frame to get something from previous and also from future. So this is another iframe. So this bullet, I mean this dot is never exit in the previous one. Okay, so it's only exit in the future iframe. So this is the information that the B frame would get, and combine these two, future and previous, and get, I mean fuse together to form another frame called as B frame. So this is the uh, features or the advantage of using the B frame. Okay, so whenever the question asks about iframe, P frame, and B frame, you should know the characteristic of each of these frames, and you should able to um, differentiate these three types of frames. Okay, so this is yeah, this is actually the things that I mentioned just now lah. So you have something from previous, something from future, and this is your ducket frame. So you will get something from the previous, something from the future, and of course you have your own percentage. Um, of course, the entire algorithm is not so simple. You know, get something from the previous, get something from the future, and then merge it together. Not so simple. In order to complete this so-called a simple task, you need a lot of different steps. Okay, for example, it will involve all these kind, which means DCT, quantization, entropy, encoding, and also the weightage. But the weightage, in order, I mean, how, what is the weightage that the weightage of features that you want to draw from the previous reference frame, and also what features that you want to draw, especially the weightage from the future frame, and how do you determine which information to drop, which information to pick up. So these all are something we so-called optimization. But nonetheless, the logic in order to do the task is simple, which is, get something from previous, get something from future, and then combine together. Okay, so this is the different types of study that we are, I mean, the the different type of study that we are actually going through. For example, in degree, this is whatever you will learn. Okay, I would say this is something basic lah. At least you know. Oh, okay. I know something about the P frame, B frame. I know how to render a video. What is the basic composition of video? But in later on, for example, master or PhD, you will need to know how is this being done. After you know how is it being done, you need to modify it, because everything would have their own limitations. So if let's say you, of course, this will involve many C6, we will say. C6 is the higher level of cognitive thinking. You will need to identify the problems, how you need to enhance it. So you will need to, maybe you need to modify the step here. For example, JPEG. Oh, I think JPEG you have this of limitation. So how do I do this to improve this uh, and enhance part of the algorithm? So that is so-called the master and PhD. And for degree, you will need to know the basic of this, I mean, the theory behind. Okay. Sometimes it's good for you all to know, uh, if, because last time when I study, I will always check what is the course learning outcome. I think you all never check, right? Uh, because the course learning outcome uh, is the key point for your examinations. Okay, so yeah, this is also one of my profs taught to us. He said he is not someone very hardworking, but he always studies something related to course learning outcome. But then, yeah, he is a prof in medical. Okay, so this is the iframe, P frame, and B frame. So you have your iframe, P frame, and B frame. Always remember I mean, P frame is depends on what, B frame is depend on what, and I frame is never depends on something else. Okay, so the iframe contain full picture information. Iframe is something like the DC coefficients, whereby it stand alone. I mean, the first DC coefficients, which means you have your, I mean, try to recall back. For example, the first one is DC is 48, and then later on you have 52, 50, 40, something like that lah. Okay, so this is so-called the iframe, which means you skip everything. The rest of it is coded using, I mean, the P frame and the B frame is coded using sort of maybe +4, maybe -2, something like that. So by code in such a way, you will able to reduce the information that you need to hold. You don't need to repeat something that you can decode from the previous frame. Rather, you just code what is the difference, and then you call back the information from the previous frame, and then add in whatever difference. That's all. Okay. Of course, in terms of algorithm, it would be a bit complicated, but in terms of information that you need to hold, is much more smaller. Okay. So the decoder can't work with B frame without the succeeding P and I frame. Okay, this is important because the B frame is something that rely on some other people. Without the information, you will not able to get. You will get artifacts. For example, sometimes when your if let's say your video is corrupted, and then you, for example, corrupt some of the P frame, and the B frame, which is dependent on the P frame, still able to play. Let's say still able to play. You will find that some part of the frame is black in color, but then some part is still appear, because those part that appear is the information carried by the B frame, where that is the differences in the information that you should add on. For example, you have a bowl of noodles, and then I have another recipe, and I only keep the differences from this bowl of noodles. So if you remove the entire bowl of noodles, so what you are going to eat? MSG, the rest of the MSG. That is the reason. Okay, so this is the artifacts appear would be the reason. There are some missing P frame or B frame, which is I mean the current either P or B frame lah. It depends on. But this will never happen to I frame. For example, I frame, your previous P or previous B or whatsoever will never affect this iframe because iframe is independent. So iframes, but we cannot keep all the iframe. Keep all the iframe is like you have a lot of different information, and the data size would increase lah. But this is the safest way you have. Okay, which means your video will never corrupt lah. When you corrupt starting from 10 seconds onwards, so the rest of it never. I mean, if let's say you have a video which is consists only of iframe, so video corruption would be solely affect that particular frame. The rest of it is safe. Okay, so this is the difference between that. And sometimes when you play a video, it is like the phenomenon like this one, like the motion is something like this one. Supposingly you have this one, this should be the smooth video. But let's say you have some of the frame is being corrupted. Perhaps you will get something with this kind of effect. Okay, it is like blocky field. It's all these frame. I mean, all these effect. Of course, this kind of effect not only because of corruption. There are a lot of different factors that contribute to this kind of issue. For example, the prediction error, for example, the corruption of part of the P frame or I frame, something like that. So depends on the questions. Of course, if the question asks, uh, you should have something like this, but you get something like this, so what would be the possibility? Then you can mention whatever possibility lah. Okay. So transmission error effect, and error within I frame data with a propagated through all frame. An error in P frame will affect the related P and B frame. Okay. Um, this is what I mentioned just now lah. If you have a error, I mean a corruptions or whatsoever error in the I frame, so this will be propagated throughout all the frame. Of course, all the frame in a GOP lah, group of pictures. If this is a GOP and you have the iframe, this iframe is corrupted, but the another GOP, this one of course, I mean this group of picture of course no not relevant because it is not depends on this the iframe from the previous GOP. So if this is corrupted, so only affect this GOP. The rest of it is okay. If you have only one GOP in the whole video, so of course all frame will be affected. Okay, and the error in the P frame will affect the relevant P and B frame. So what it is? Example frame with I and P frame. Prediction. Da, da, da. Okay, so this is just to um, um, illustrate how the P frame and B frame is being predicted lah. But nonetheless, the P frame and B frame are not emerged from only the characteristic of P frame and B frame is that it will get something from previous, and B frame will get something from previous and uh, future. Okay, but not a must one frame before the P frame. For example, it can skip three, you can get something from here. It depends on the algorithm. Okay, but nonetheless, the characteristic is that P frame will get something from previous, and B frame will get something from future and previous. Okay, not a must you get the one. The one just adjacent before or after the P or B frame, not a must. Okay, so this is to illustrate like this is the I frame, so it will contribute to this P frame, and this P frame contribute to this P frame, and we can say this is one GOP lah, because this is another I frame. Okay, we can say this is one GOP. Okay, and for this one, you have I frame and then B frame, B frame, P frame, and then another BB. Because P frame will never get the information from B frame. So that is why it will skip the B frame and get the nearest before that. In this case, it's an I frame. Okay. So yeah, something like that. Okay. So pictures are encoded and decoded in a different order when they are displayed. This is due to bi-directional predictions for B frame. Da, 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 da. Okay. Below is an example to illustrate reordering of 12 picture of GOP. Anyway, this is just FYI, because we will not going to learn the algorithm, how they shuffle the encoding system. Because this is the source or the input in at the encoder, and this is the encoding order, and this is what we display. So basically, when you see this, you will find that, how can I? Why cannot? Eh, why, why so many technical issue? Okay, so you found that actually this value is same as this value, which means everything is in the source or input order is same as whatever display at the output. But you will find that actually the value or the order in the encoding order is different. This is depends on how the algorithm shuffle it and how the algorithm manage the data. For example, I want to manage in A method, then maybe some algorithm want to manage in B method. It's up to the algorithm. But this is we are not going to learn this. So just letting you all know that the most important is that the source input and the output must be the same. If it is not same, which means something that you code now and later on display is something different. Okay, so that is no way lah. Okay, so anyhow, the shuffle, how the encoding is being shuffled is different. So you have when you can observe that the I frame, B frame, B is P, B frame, I is I frame, P is P frame. The order is different here, and it is actually same here. So this is the order actually lah. Okay, and this is how they reshuffle. MPEG display order I B B B P. Okay, this is actually same as this one. The idea to deliver the message to deliver is same as this one. So the forward prediction of P frame. So-called forward prediction is that this particular P frame is actually getting something else from the previous I frame. Okay. Always remember the P frame will never get information from B frame, and uh, this frame is actually getting information from the previous P frame. Okay, and this B frame getting information from the uh, previous I frame and the future P frame. And this get something from previous uh, P frame and the future P frame as well. Okay, so which means I frame never get something else from something another frame. A P frame always get from previous P or previous I. B frame will get for I P, yeah, I and P. Okay. Anything I miss out? No, no, no. No. Okay. Which means no one will get the information from B frame lah. Okay. The I frame are intra-coded. They can be reconstructed without any reference to other frame. The P frame forward predictions from the last I frame of P frame. So that is, it is impossible to reconstruct them without the data from another frame. Okay, so you were not able to create the iframe from or p, I mean the p frame or b frame without the reference frame. So you, if let's say the reference frame is being corrupted, so that's all lah. Okay, so that is why sometimes the corrupted video can be recovered, sometimes cannot. It depends on which frame is being corrupt. Okay, the B frame are both uh, forward predicted and backward predicted from the last or next I frame or P frame. There are two other frames necessary to construct them. So P frame and B frame are referred to as inter-coded frame. This is inter and this is intra. Okay, this is to illustrate the difference. But I did not actually say which one is. But anyhow, this is iframe, this is iframe. But between these two, I also not very sure how to differentiate. I think it's no way to differentiate if it is not mentioned by the. I mean, not mentioned by the algorithm itself. So anyhow, the number two, number three, and number four, frame number two, three, and four is no way to be iframe. Is either P or B frame. That is because this is the top up, I mean the difference in terms of frames. So whenever, if let's say this frame is being corrupted, so what would happen here is that the rest of these portions would become big black in color. So you have only the rest, the difference from the rest. I mean, those information that is held by the this current frame, P or B frame. Okay, the rest of it would appear as black color. So summary, decoding P and B frame are much more complicated since that depends on other frame. Not only decoding, even encoding them is much more difficult. But the return point, I mean the trade-off is that you save a lot of space. Okay, P and B frame are encoded using motion vector that indicate how much each macro block, 16 or 16 or 8 times 8 pixel of the reference frame has moved. Okay, so the idea is the same as the JPEG conversions, whereby you will check the frame, the 8 times 8 or 16 times 16 block frame, I mean block by block for the entire image. Okay, any question regarding IP and B frame? All right, so this is the last part. Let me see, yeah, last part already. Video compression standard. So this part is regarding the standard lah, like the NTCA, SCAM, and etc. So different image or video compression standard used in different used in application. So basically, this I would say this is the common standard being used lah. Nonetheless, if you want to use something odd, it's okay. Just that not sure is uh, the current instruments, multimedia instrument can play or not. Okay, so VCD, you have to store the video. You have MPEG 1, digital TV or DVD, you have MPEG 2, digital camera, you use JPEG, and 3G video call is MPEG 4, and video conferencing is this one, and mobile is using this one. Okay, so these are the basic informations for the video format, raw data, and also compress rate. But nonetheless, all these are so-called something fixed, like, how many eyes a human have, so it's two, something like that. So it's being fixed. Actually, this is the information for this kind of different standard. Okay, no need to memorize this one. Okay, this is the compression for this kind of standard H.261 and H.263. So H.261 compression has been specifically designed for video conferencing over telephone line with a low bandwidth. So video telephone application over ISDN, telephone line, which is the baseline ISDN. This is the bitrate. Similar technique MPEG standard, but lack of advanced MPEG techniques to provide efficient bandwidth use. This is bandwidth. H.261 and H.263 are not suitable for usage in general digital video coding. That is because the transfer rate of the bandwidth is different. So you cannot really, you can use maybe the deliverability is very uh, bad or very low. Okay, so MPEG 1 only support progressive scanning here for progressive scanning with a reference rate of 30 Hertz and 25 Hertz. So initial audio video compression standard as well. And this standard is upon the same technique used in JPEG, including the efficient coding of video sequence. So MPEG 1 is intended to store for digital audio and video on CD-ROM and we have a bitrate up to 1.5 Mbps. And each frame is divided into macro box. This is X, 16 times 16 pixel for compressions. So in MPEG video, only new parts of video sequence is included together with information of moving part. New part of video included. Okay. The goal is on compression ratio rather than picture quality. So whenever people use MPEG, depends on which layer is it. But usually when we use JPEG or when we use MPEG, we are more focusing on compression rather than the picture quality. So I believe in your assignment or the lab, you already know that the first, I mean like the first question in the lab assignment, lab report is to compare between TIFF and JPEG, right? So when you compare TIFF and JPEG, so you know that it's odd when you want to analyze the image, but you are storing it in JPEG. Since the calculations, the value of the bit size is very different, very big difference to the one displayed. I mean, when you check using the MATLAB, the file size is much more smaller, right? So this is the reason why when you're using JPEG, you would already expect something like this. So you will, I mean, as an image, I mean, as an engineer, if you want to analyze something, especially analyze the image, it's no way for you to step in JPEG. So I believe you all know the reason why, okay, after the assignment and also the lab report, okay? So whenever people select the JPEG or MPEG, you already know that they are more focusing on compression rather on the picture quality. Of course, we try our best to make the trade-off, but the weightage or the priority for sure will be in compression ratio. Okay, um, do acknowledge some of this one because not every time everything would be reckoned out very clear, but sometimes the message in the questions might imply something else. Okay, and I think you all are quite well versed in using computer. Uh, I'm not sure if you all are still good in writing using pen. So please prepare, okay? Especially for the face-to-face exam. So everything, I mean, no computer will be allowed. So no matter how fast your typing speed is, if your writing is not so good, habis. Different vendor implement MPEG encoder that produce video stream that differ in quality. So issue need to buffer in real-time transmission of MPEG, hence inevitable delay in an important issue or low bit rate. So basically, when you have okay, so if you want to stream with different quality, especially you want to stream something with big quality, I mean the high HD video and etc. But last time our bandwidth is not so uh, I mean, not really able to support the video. I'm not sure if you all know, last time when we watch YouTube, we need to buffer it. Now still need, all right? I think no, right? Last time we always, before go to bath, we open the YouTube we want and then let it buffer. To be frank, that is the old glory time. But now I think no need already. Although we always complain that, oh, why is this, I cannot connect, I slow, something like this. But last time we really need some time to buffer it. So that is what we are doing. If you know later on you want to watch the drama or watch the movie, make sure you buffer your video. So it's some the issue because you need if you have a high quality or HD video, for sure you have a longer buffer time. So but of course when we have 5G, 4G, 6G and etc. So the buffer time would be shorter and shorter. But nonetheless, if you are playing a very big video, for example, those video teleconferencing, teleconferencing, which means you are real time observing the scope or whatever in the patient body. And that one need really high, I mean, HD video. If not, you would cut the wrong artery or vessel or vein and etc. So that is what is so-called the main purpose. Of course, the main priority is to serve the public, but nonetheless, we have some extreme cases that require really high bandwidth. So that is the reason people are talking about 5G, 6G, and there would be issue among different country and etc. Because we are not talking, oh, we need to buffer for YouTube or something like that. They are talking about higher level of message transmission, like the medicine, like the security encoding and etc. So this is the issue that the country is looking to, not something that I cannot buffer my video. Okay. So sometimes we cannot really understand why they keep arguing on something, 5G and 6G, something like that. But that is the reason why. It involves a lot of military issue inside there. Okay, MPEG 2, basic coding structure, the same as MPEG 1. So you have intra-frame and inter-PCT, uh, and iframe, pframe, and b picture as well. It was developed as a standard for digital TV broadcast, provide high quality video with bitrate around 4 Mbps. So this standard is targeted primarily at interface, interlace, I interlace sequence video input at higher resolution. So more sophisticated motion estimation method frame field prediction mode are developed to improve the estimation accuracy for interlace and sequence. So in order to produce the P frame and B frame, we are always using the motion estimation method. But of course, there are several types of motion estimation method, and where we did not learn in this, not in our syllabus. But nonetheless, you should know, in order to create the P frame or B frame, it is about how motion estimation method is being applied. And if the motion estimation method is very good, so you would have a high quality P frame or B frame. Else, you would get something like the blocky feel, like the construction man that I showed in previous slide. I mean, in this lecture. So H.264, this is another standard, latest generation standard for video encoding to provide flexibility to allow the standard to be applied to a wide variety of applications for both low and high. So you have low and high bitrate resolution and demand. This low and high is referring to these three, okay? Which means it cover a wider variety of video, no matter it's in terms of resolution, bitrate, or the demand of latency. And the applications, entertainment video encoding broadcast, satellite and cable. So telecom service would be less than 1 Mbps, which is low latency, and streaming service would be low bitrate. So the summary, you have MPEG 124. Actually, MPEG 124 is the MPEG layer 1, MPEG 124. One moment, let me check. Okay. MPEG 124 is different types of MPEG. The more effective than motion JPEG in most cases, and MPEG 2 provide even more advantage and support better image quality, and it's require more network bandwidth consumption, and is a lot greater in complexity. MPEG 4 developed to offer compression techniques for application demanding less image quality and bandwidth, and also able to deliver video compression similarity to MPEG 1 and 2. Basically, the idea here is that same as the audio processing, whereby you have MPEG 1, and MPEG 2 is including everything in MPEG 1, and MPEG 4 is including everything in MPEG 1 and 2. Okay, I would say MPEG 1, MPEG 2, and MPEG 4, something like that. Okay, so this is the relationship between these different types of MPEG. Okay, but nonetheless, MPEG is not something that we are going deep inside. But for the audio compression, you need to know. For audio compression, you need to know. I think in audio compression, we talk about MPEG layer 1, 2, and 3, right? For MPEG layer 3 is MP3 that we always use. And for audio compression, you need to know the difference between these different layer. And um, how the psychoacoustic model is being uh, applied, how the PCM is being applied, sorry, PCM is being applied, and what else? The bit rate what? Bit rate filtrations or what? To convert it to bit rate. Yeah, how that one is being applied. Okay, that's all for the syllabus in MTAA. Any questions? Any questions? No. Anyone? Any question from online? Okay, so we will again now we will have for the next lecture. Today we don't have any tutorial, and for next Tuesday we will start. Later on I will upload the tutorial question. The rest of it we total we have 9 tutorial. So next Tuesday onwards we will start doing the tutorial, and we will try. Please try to complete lah because I randomly to call upon you all to complete this. But I know you all will not study this one so early lah because it is in May, right? 5th of May. I understand. So perhaps depends lah. If let's say you all later need revision, I mean really need some part of explanations, you can email me and let's see if I can make it. Okay. If not, then that's all. Lor. Okay. Any questions you can email me lah, or you can send it to Chia and Chia send it to me. Okay. So if no questions, so that's all for today.
Sir, can you
Yes.
hear me?
Yes,
Can I
we
ask you
can.
something about the B frame, the
Yeah,
bidirectional frame?
please.
So I saw in the slide some B frame is actually how to say some groups they are actually contain multiple B frame. So of course we know that the first one will be the I frame and the last one will be the P frame. So may I know so actually if the bidirectional frame in the middle, let's say there are two layers. This one. So the first one will take from the I frame and the P frame. How about the middle and the third one? Will it take from the B frame or take from if? But yeah, I was thinking should it take from B frame? Because is if it take information from I and P frame, then if the information will be duplicated.
Okay. For these questions, it is actually as I mentioned before, the B frame will I mean nothing will taking from B frame. So it's I think your question is that why these three B B B are taking the same thing from I, taking same thing from P, right? So is
Yeah,
it
yeah,
all this B frame is the same represent the same frame? No, it is different. That is because we have it is again this is depends on the algorithm. For example, you imagine this is a continuous motion. For example, from this point until this point, it is a continuous motion. You have your motion in I, your motion in P. Let's say P. One moment. You have your frame. This is the I. This is the P, and this is the B1, B2, and B3. B3. Okay. So the theory is that the B frame always gets something from previous and from future. So the nearest previous would be this iframe, and I mean now I'm talking this B, and the next I mean the future P frame or I frame is this one, right? So it will get information from these two, but nonetheless, the same apply to B2 and B3. But although they are getting the same I mean getting the information from the same I frame and the same P frame, but the weightage of the degree or the degree of the information getting from these three frame, I mean this I frame and this P frame is different, which means you maybe you have someone walking, and then this is the I frame, and then this is the P frame. Maybe a ball is arrived his hand, something like that lah. Okay, so you have B1, B2, and B3. It depends on how many B frame you want to chip in between this I and this P frame. Let's say you want to chip in three, so you can I mean depends on the algorithm on what kind of weightage the motion here, the motion here, and the motion here. For sure, the motion for these three frames is different, but the main frame that you can withdraw the information must be this I frame and this P frame for this three B frame. Can you understand? But what is the weightage or what kind of information being retrieved from this I and this P frame? It depends on the algorithm. What level of information is being retrieved. If let's say you want to have, oh, I want to have more details. A very smooth of action. So I want a 10 B frame here. So I will have B1 until B10. But B1 until B10, we are still getting the information from this I frame and this P frame. But the degree of information is being partitioned into 10 different portions. So 10 different portions will be held by B1 until B10. Can you understand this one?
Yeah, I think I
Mm.
get it.
Okay, so that is why from this point you will find that, oh, why there are some came from the same iframe and came from the same key frame, but nonetheless there are three different B frames here. That is because they partition the motion, a continuous motion, to three different portions. If you want to partition to 10 different portions, which means the motion is more and more sensitive and more detailed. So that is this. And of course, you will increase in size as well. Okay?
Okay, thank you, sir.
Okay, good. Okay, any other questions? No, okay. Good to know you all have questions. Okay, and good luck for your examinations, and we'll see you all on next Tuesday. That's all for today class. Thank you. Of course, because you when you see durations, you have iframe, you have iframe, maybe you have p frame, p frame, I p frame. You can see if you are talking at this instant, for sure this is future, right? But if you're talking this instant, so this is previous already. It depends on which instant you're talking. No, 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 no. It depends on how the user render the video. Not a must. I only can tell you in the composition of a video, you have iframe, p frame, and b frame. So iframe is the independence frame, p frame is getting from previous, b is previous and future. That's all. So how they want to manage this one is like you have a Python, you have a MATLAB. How you want to do your coding is up to you. So you don't have any uh fixed sequence like I P P P B B. No, 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 not no such thing. Okay.